Okay, so today, hopefully we're going to finish up with basically all the prelims before we start actually working on the data structures part of this course. I feel bad, I feel like we've done a lot of work of not data structures, but that's okay. Everything you've learned should help you greatly understand data structures as we move forward. But today we're going to finish up, we're going to talk about OOP, namely the differences between C++ and Java. And then we're going to talk about C++ testing. Did y'all do any testing in OOP or procedural? Not even, did you do procedural?
Test cases?
Yeah, test cases.
Yeah.
No? Not too much? All right. Well, I'm going to tell you now, I'm not going to force you to write test cases, but if you don't, that's your own funeral. So I highly recommend you do it. We're going to go over pointers again because they're very important. So hopefully that section will be a review. And then I'm going to basically show you how the final evolution of makefiles occurred to what we're going to use for the rest of the course. Yes?
So for test cases, do we have to leave them in the code?
No. I'm not going to test your test
them.
cases. Oh no, you can submit them. I'm just going to ignore them.
I just take them and I'm like, all right, this was input at one time. I commented it out or I delete it because it's no longer needed.
I'll show, once we get it all set up, what's going to happen is your test cases are going to be in a separate file than your code. So I'm only going to grab your code in certain files. So just make sure that code is clean. You can write your test cases in all those other files. You can do whatever you want. I don't care. I'll ignore it and just test your code. So, which is how it's done anyways. Okay. So C++ shares many similarities to Java, namely because Java is based off of C++. But the objects in C++ are generally considered more powerful. First off, they can be created on the stack. I think I showed you that beforehand, where in Java they were always in the heap. C++ they can be created on the stack, which helps you with allocation and deallocation. C++ allows multiple inheritance. Do you know what that means? Do you remember inheritance? What is inheritance?
Yes.
So, right. So you have a mammal, and then maybe you'll have cat inherit from mammal, and then tiger inherit from cat. In Java, inheritance was single, unless you use something called interfaces. In C++, it doesn't care, it'll allow you to inherit whatever you want, and tries to figure everything out from there, which makes it more complicated for the compiler, but hopefully easier for you. Namely, there's no need for interface. And then templates act like generics, except they're compile time and not runtime. And did y'all say y'all didn't get to generics? No, okay, so we'll just talk about templates here. The big key thing to keep in mind between C++ and Java is that C++ is compiled to machine code, Java is compiled to bytecode, and then you need a Java virtual machine in order to run your bytecode. So there's an extra layer there with Java. C++ just compiles straight to your machine, and then you run it. Okay, so quick review. How do you access, I guess, enforcing thorough access? Public, private, and protected are basically still the same in Java and C++. As I showed you earlier, you just have a section for public, private, and protected, as opposed to having to put it in front of every function or variable like you did in Java. Right. So in Java, everything's prefixed. C++, you have sections. There's a friend keyword in C++. You didn't have this in Java, but in friend, what you can do is if you have one object, you can say that another object is your friend, and then that other object can reach into that first object's private parts, or private member variables. So, I'm going to show you what this is, and then hopefully you'll explain to me why this is bad. Oh look, I forgot to set up the camera. All right. So, we'll just say you have object A and object B for lack of names right now. And of course you have public stuff good old technical term, and then private as well. Okay, and you have object B. Same thing. Object B. What does object B have access to in object A? And just standard. The public stuff, right. So object A can access this, but he cannot access this, right?
Right.
Okay. In C++, if you wish to change that, you can say inside of a, we'll do it this way, because I'll show you, I'm not going to show you the syntax because you should never do this. You can say, wow, let me try typing again. And by typing, I mean writing. Friend B. Once you declare B to be a friend, this is now okay. All right? Why is this bad? Yeah, so B can now modify any part of A. Yeah. So what does that mean? In C++, friends are bad. Friends are bad. Everyone got that? All right, good.
So C++ trust no one. Got it.
Yeah, yeah. Trust no one. There is no trust. Oh yeah, well, there is definitely no trust. Okay, so friends are bad. Inheritance. Methods and attributes are inherited. The difference is mainly syntactical. In Java, you would do public class A extends B. In this one, you do class A and then colon public B. There are different types of inheritance. You can public B, private B, or protected B. Private B doesn't really make too much sense. So just stick with public B, and that's going to be the same thing for now. You can actually, if you have a class C, you can do public B, colon, public C, and then it would inherit from both. And C++ would allow that. We're not going to go too much into OOP for this course. You okay?
I'm good, yeah. It's like on the screen.
So like secret messages going around? Okay. Do you have a question?
Well, I was going to ask if private B, since you can do that, will that actually inherit the private information, or is it still?
No,
can't
it's
inherit
the,
information?
it delineates the access from A. So it'll inherit from B, but everything's private. It's kind of, you wouldn't use that very often, right? Okay. Parametric polymorphism. This is with generics in Java versus templates in C++. They're different, but we're going to go over that later when we get to it, which will be later on in the course. Just realize that there is a difference, but for most of y'all, it'll be all new, so that's okay. All right, pointers. I mentioned this a little bit. In Java, a pointer was called a reference to an object. String str equals new string. In C++, a pointer stores the memory location of something else. So for object, you have standard string str equals new, standard string hello. So these two lines are basically the same, because str up here in Java is actually a pointer to a string object. It's just down in C++, if you want your object to be on the heap, you have to explicitly make it a pointer and then call new afterwards. I think we went over this a little. Is anyone confused by this or want me to explain it again?
Could you please explain?
Please explain it again. Sure. So, Java string always on the heap. This is actually a pointer, but the variable str. Let's see. The variable str. Where does it reside? What piece of memory? You recall? We had static, stack, and heap. Where does the variable str reside?
Stack.
On the stack. Because str is being declared over here. It doesn't have new in front of it. So it's being declared somewhere, which is on the stack. That variable is holding the memory location of the object string that was allocated on the heap. So str is a static, or not static, variable that exists on the stack that points to a string object, and that string object it's pointing to is on the heap. This is the same in both. Now, what could you do in C++ that's different? Well, you could just have standard str semicolon, and that would automatically allocate the string on the stack. There wouldn't be a pointer. You would just be accessing that string object directly on the stack. Of course, it would be deallocated at the end of the function. All right. So another explanation, a Java pointer only exists to objects. A C++ pointer may point to anything. All right, so you have a constructor, just like in C++ Java, for when you want to construct your object in a default constructor with no additional information, and of course user as well. All right, let's go ahead and jump over to some code. Hey, you can always say, show me the code. Show me the money, show me the code. Yeah, the same thing. Both will work. All right, class code. mkdir, let's go objects. Yeah. All right, what do you want to make a class of? Quick. Tomatoes. What's funny is now I got to remember how to spell tomatoes. All right, .cpp, great. Class, tomatoes. Notice it doesn't have to start with a capital. I don't know how to spell tomatoes. So, there we go, class tomatoes. Is that wrong? Good. Oh wait, is that too hard to read from back there?
That's good.
You're good? All right. So we can have our public section and our private section. All right. What do we want our tomatoes to have publicly? Okay. Maybe int number of seeds. Okay. Anything else? Amount of what? Oh, tomatoes, because this is more than one tomatoes. All right. Okay, int size, sure. Int color.
Is it bright red tomato or is it
We're going to pretend they're integers just for the sake of argument.
Age.
What's the last one?
Age.
Age? Okay. And we'll do get age. Let me go ahead and actually follow good OOP principles here. Get color, get size. All right, so private members probably is going to be int. Let's go int seed count. And maybe int. I'm just going to call it a color. int age and size. What was size supposed to be? The number of tomatoes or the volume or number of tomatoes? All right. Number of seeds. Okay. I'll just call it size.
Why do you put an M in front of it?
So I follow the Google convention of all member variables start with the letter M, and the reason for that is it makes it's obvious when you're coding what variable is a member of the object and what is a temporary local variable. It's a coding practice that will makes your code a little easier to read.
Okay, yeah, so instead of like having to just manually look for the same words, you kind of like just look for N.
Yeah, if you see M in front of it, you know it's part of the object. Well, yeah.
Well, no, mine's just, can we go ahead and change get color to a string? That's no problem.
Yes.
So anybody can access the public value. Nobody can access the member value in private.
Correct.
Other classes. Let me see.
All right, now we got to actually include string. Okay. Wow. All right, let's go ahead and make main. So let's go ahead and make some tomatoes. Tomatoes. I'm going to call it toe. All right, there we go. And let's just see if it compiles, because that'd be great. Oh, it compiled. It's amazing. We'll run it. Hey, look, nothing happens. Okay. Oh, we don't do anything. Yeah, okay. All right, so first off, we can do a constructor. And you probably want your constructors to be public. Well, actually, let's go fix these functions real quick. Get number of seeds, return m seed count. Get size, return m size. Get color, return m color. And then age, return m age. So if we're down here, we got to include IOStream. I need that like a little button every time. Yeah! Yay! Woohoo! Okay. Alright, so we can do toe dot, oh wait, we'll say seed count, toe dot number of seeds, \n. Alright, now we'll just copy this one more time since you C2W size. This one will be color, and this guy will be age. Whoops, I forgot to delete that thing. So this one would be get size, this one will be get color, and this one will be what? Get age. All right. So, what do you expect this to print out? Okay, so what's going to be after seed count?
New line.
What?
New line.
A new line?
Nice.
Well played. But after seed count and before the new line,
It would be the value.
it would be a value. Okay, we're doing great. Moving along.
Would it be a 0?
There it is. Brown brown.
I said 0 or
Undefined.
Okay, it's undefined.
It's undefined. It can be anything. If you said it back there, speak up, okay? All right, how about after size?
It's gonna be.
It's not going to be undefined.
What?
Look, we said size.
Size, I'm not size. Oh yeah, size will be undefined. What about color? There we go.
Color. It's just an empty string.
Yeah, why is it going to be an empty string? Not null was a good guess. Who said null? Good guess. Good guess. But why is it an empty string and not null? C++ is like that. All right, what is That's what I heard someone say. I don't know if that's what you actually said, but that's what I heard. Okay, what is mColor's type? It's a string. Is it a pointer to a string? Wait, hold on.
No, you didn't say.
No, is it a pointer to a string? This is not Java. No, it is the actual string object. So it is instantiating a string object automatically for you right there. Because it's not a pointer. So it's automatically instantiating a string object, calling the default constructor for a string, which happens to be an empty string. And then age is going to be undefined. Good. Yes.
So if it were a pointer, then it would be null, or would it still be an empty string?
If it was a pointer, well, hold on. Let's first make sure we're correct. Because, of course, we have tons of beautiful errors. Return mColor, probably need a semicolon. And then we have too many semicolons down here. Let's get rid of these semicolons. Oops. Yeah, there we go. So yeah, undefined. If I ran this again, some different values. Okay, great. Size seed just happens to be 0. Now your question was mColor. If I made it a pointer, what would it be? Okay. Well, if mColor was a pointer here, then getColor needs to return a pointer, right?
Yeah.
Okay. So then, what is it going to print out?
We would print the space of memory as taken out.
That what's taken out?
That the pointer is turned out. So the heat.
It should be. It's in, right. What does a pointer hold? a memory address. So what memory address is it holding?
Wouldn't it change every time? Like, these all these are doing?
Yeah, it would change every time we run the program. Why?
Because we're not deleting this, we should take it its own place.
Hold on a second. What'd you
If
say?
it's going in different places every time, it's in the same place.
Okay, yes, but what's actually being printed off here?
Isn't it memory?
A memory address is being printed off. Have we set that memory address? No. So it's whatever was in that object at that time. So I think that might be what you were getting at, kind of. But just to be very explicit, when the object's created on the heap, it's saying that this piece of memory is going to hold a pointer to a string, but then it doesn't initialize what that memory is going to be, so it can print off whatever happened to be there last. Happened to be 0. Hey, look, seed count went to 142. If I ran this enough, eventually we'd probably get something else. But right now, color 0. It's important to realize that that just happens to be the case these number of times I've run it. It doesn't always necessarily going to be 0. Doesn't necessarily always, sure. All right, let's make it back to this. So it's automatically an object that's part of the object. Okay. So if we want to initialize these variables, what do we use in Java? You could use input, right, but after you have the input, what do you have to do?
You have to have a setter method.
You have to have a separate method.
A setter.
A setter. Okay, we'll do setters. I like setters. All right, so void set number of seeds int seed count. Whoops, with lowercase s. Now notice here, this is why I use the member thing, because I go in seed count equals seed count, and then you can tell that this variable is part of the function, namely up here. Well, this guy over here is a member of the class. That's why I put the in there. So int set size, int size equals size, and let me be consistent. I for some reason put a space there. Let's see. So void set color, string color, and then lastly, what have we got? Age. All right, int, actually void set age, int age. Wow, today must be a rough day. All right, so we have some setters. So down here in tomatoes, we can go toe dot, was it set number of seeds? We can give it 100. What else do we have? Was it set size? Set size. 10. Set color. What color do we want it to be? Green. Good old green tomatoes. Set age. What's the age of these tomatoes? 10. All right. So now let's go and run it. Okay, look. Now it's going to stay that way each time. All right, beautiful. Okay, so we had a setter. Now we have setters. What's another thing we can do to set these?
CN.
CN. Okay, so you do CN. What function would we use to set these variables when we create the object? Constructor. Okay, good. So we went through constructors. All right, so let's go ahead and make a constructor real quick. Let's call it, it's still under public. It doesn't have a type because it's a constructor. And then you usually give it a list. What do we want to do? Int seeds, int size, string color, and then int age. So we'll go set, what was it? Wow, I don't want to type all that out. Y3 down. All right, much better. Okay, then we're just going to call the setters. Why am I calling the setters as opposed to setting them in here? I mean, couldn't I have done what's it called? Seed count equals seed, or seeds, I should say. Actually, I should set all these correctly, shouldn't I? Size, color, and then age. Okay. Good. Bad. Why is the first one preferred? Well, Tomato still has access to the private variables, but I think you're on the right track.
Oh, for the parameters? Seed count?
Let me first make sure the code compiles so I'm not confusing anyone. Nope, tomato toe, no matching function call. Right, so now it wants us to actually make the constructor, the default constructor. We're just going to write that for now, even though it's a terrible default constructor. Okay, good. All right, back to this. Why is the first one good, the second one in general considered bad? No.
That's how I stop both ways.
All right. In the good way, how many places do you update the seed count? 1. In the bad way, how many places do you update the seed count? 2. 2. So if you need to all of a sudden write a piece of code that whenever the seed count was manipulated or changed, do some complex operation, in the good way, how many places would you have to change it? 1. But in the bad way, right. And then if everyone was doing it the bad way, instead of doing it 1, it might be 20. And you got to now go through your code and find it. So this is called good programming practice because now there's only one place that actually sets the variable. Everyone understand?
Yes.
All right, good. All right. So let's actually go in tomatoes here and use the constructor. All right, and there we go. Now I'm calling the constructor that we just created inside of main, which then sets variables. All right, where does the tomatoes toe? Where does that variable toe exist in memory? Static, stack, or heap? Stack. So if toe exists on the stack, where does color of toe exist? The stack. Correct. It exists on the stack as well. All right. Now hopefully we can all tell if we do, we'll call it toe2 equals new tomatoes. And we'll copy pasta this real quick. Ooh, that's not good. What did we miss? Oh, we didn't do age. Okay. All right. So what's this? What is this line doing? Oh, we need to change this. But let's say what it's doing. What is this whole line doing? The one my cursor's on. All right. So first, it creates a pointer in which piece of memory?
No, that's on the
Stack. The pointer's on the stack. And what is that pointer? What are we calling it? Toe2. And what is it pointing to?
The tomato object.
A tomato or tomatoes object. Correct. All right, so that's what the left is doing before the equal sign. Yes.
So to clarify, if you were to ask where toe, where the variable toe is stored, you could say stack.
Correct.
Okay.
That one's on the stack. But toe2 actually toe2, where does toe2 exist? Still on the stack, correct. Toe2 is still on the stack because it's a pointer to a tomatoes object. But that object it's pointing to exists where? In the heap. All right, we should give this something different. So number of seeds, we'll say 500. Size, we'll increase it to 50. What color do we want this one to be? Blue, red.
Okay.
How old? 2. That's a youngin'. I don't even know what that means. All right, let's run it. Hey, look, things are wrong. Yep. Because since it's an object, or I'm sorry, since toe2 is a pointer, we need to use the arrow. Because you have to dereference toe2 first and then jump to the location. All right, there we go. Now, so the object that toe2 is pointing to exists on the heap, right? That object's in color exists on the heap as well, right? So the object toe2 is pointing to, its in color exists on the heap. But toes, regular toe, TOE, its in color exists on the stack. Okay. Okay, I think that's good for now. Any questions, comments, screams? No screams? Okay. Sure. All right, we got default. Oh, okay, here we go. All right, guys. One of you is going to write this. What should that do? Right. You think this would call the default constructor. Well, let's compile it. And it worked great. So that time it worked. Sometimes you're going to write this and it's going to say undefined function because it thinks toe3 is a function. Just keep that in the back of your mind. It's going to do that to you. Just wait for it. It's going to happen.
So was it not supposed to work?
It was not supposed to work. Maybe they finally fixed it. Oh, they fixed it. That's amazing. All right. I'm glad they finally fixed that. So good. That error no longer exists. Thank you. Yay, whoever said that. Thank you. That was really annoying. Okay. In Java, arrays are actually objects that store length and other information. So since in Java an array is an object, where does it exist? In what piece of memory? It's an object. All objects require new, which means it exists on the heap. In C++, an array is a sequence list of data. Nothing else is stored. So int x20, button b20. Where are those variables located in memory? Then C++, well, you can't. Well, I actually can't do that Java. In C++, valid C++, not really in Java. Why? Unless they change that. Right, well where does, right, the first one creates 20 integers, or ints, but where is that stored? Static, stack, or heap? Stack, right. So if I were to go down here and go int x sub 20, on the stack. But if I do int x equals new int sub 20 on the heap. Yes?
Do you need a pointer for anything you put on it?
Whew, that's a loaded question.
So I'm just curious if you could get rid of that asterisk, make it still work.
Okay. So the answer is, of course you can do it, but don't. Please don't. All right, and I'll show you why in a moment. So when you have a new, what should you have?
Delete.
A delete, right. So if we were to, well, let's finish running this, and we Valgrind it real quick. we say, oh look, definitely lost 128 bytes. That's because we didn't delete X and we didn't delete X, or not X, I'm sorry, X is. And we also did not, let me put in a semicolon, delete toe2. So let's go ahead and delete those guys. Well, we should compile it first. And what's happening here? Mismatch free. Oh. Because it wants that. Now it's, oh. Come on. Okay, now we're better. All that error was saying is that if you have an array, you want to use the delete with the brackets. All right, so now we have no memory problems at the end of our program. In use at exit 0, we allocate it, but we freed, so everyone's good. All right. Okay. So can we just create something on the heap without having a pointer to it? Sure, why not? Let me run it. See? It just created 100 integers on the heap. Right? Right. How would we free that? You don't, because we have no way to point to it anymore.
Oh, so you have to, if you use a variable to reference something on the heap, it always has to point. Is that the case? Or
Yes.
Okay. It couldn't just be X equals.
No. Nope. If it's on the heap, you have to point to it.
Okay.
But on the stack, you can either need a variable or point to it. All right. So don't do this. Just because you can doesn't mean you should. All right. Pointers of arrays. There's a close relationship between pointers and array. Right, I just showed you this. A new way to allocate the array on the heap is like this for dynamic allocation. And then you delete it with the brackets. I think we've actually gone through this, so we're good. In Java, the constructor is invoked only through the new keyword. C++, it's called upon variable declaration, which can happen in different locations. For example, right here, we called the constructor from variable declaration on the stack, from here on the heap. What was also implied is that since mColor is an object from the standard library called string, before the constructor is called, the default constructor of mColor is actually called as well. It's kind of a hidden feature of C++ that's hard to see, but yes, mColor's default constructor was called before our constructor actually began. Is that confusing, Xavier? So, let's see. All right. Let's make a class called, I'll just call it seed. Public. We'll have the default constructor for it, and all we'll do is cout constructor for seed called. Okay? So all this class does is when you call the constructor, it prints something out. Let me run it, compile and run just to make sure we're still good. All right. I'm going to comment out a bunch of code just so I can show what's going on. Okay. So let's go and give it a seed. All right. Notice I just declare seed right there, but I never initialize it. C++ is going to automatically initialize it as part of the class. For example, when I go ahead and run and compile, constructor call for seed called. It's a part of the class, so during the construction, it's actually called. So tomato toe is called down here. The question is, when is that constructor called? Well, let's go ahead and put a little print statement right here. It's not called count. Tomatoes constructor is called. Oh, this is not printf. So the constructor for seed is called first, and then tomatoes constructor is called. Okay? That's how C++ works. It's going to call the constructors for your private member variables before it calls the actual objects constructor. Now, can anyone think of how we could get around that? I'm sorry, public?
This object public, because you said that was private.
Okay, we could make it public, but that's not going to change when the constructor's called. It just means anyone can access it. So you could take this, we'll put it up to the public section, compile and run. Again, the seed constructor was called before the tomatoes one. So this didn't really work out. Let's go and put it back. What else could we do?
Initialize it? You don't want to do that.
Right. We could initialize it in the constructor, and that's actually a pretty good guess. But unfortunately for C++, it's not going to do anything. I mean, what are we going to do? Equal. It doesn't actually. How do we set it? We can't set it right now because it's on the stack. But you're on the right track. Whoops. What could we change MC to be? Instead of the object, we could make it a pointer to the object. Right, so we made this a pointer. All right. If we made it a pointer, if I just made it by making it a pointer, MC is going to point to a seed object that exists, well, it points to a seed object, just period. If I run the code as it is, what do you expect to be printed out? The tomato constructor will be called. Will the seeds constructor be called? No. Why not?
Because there's no object that it points to.
Right. We have not created an object for it. So let's go back over here. Tomatoes constructor is called. We haven't called the seed. So now inside of seed we can do m seed equals new seed. Down here, call it, and now the constructor for seed would be called at a later point. But now we have to deal with pointers. You see what's going on? No? Here's a good question. This will probably help. All right. TOE. What piece of memory does that exist in? The stack. Great. So the object toe exists on the stack. Its member mColor, where does it exist? On the stack. Okay. Hey, look at that. Not going to happen. mColor exists on the stack. Great. All right. Now hold on. Be careful. mSeed. What's mSeed's type? It's a pointer to a seed, and it exists on the for the object toe. mSeed exists on the stack. Correct. It's still on the stack because it's a pointer that's a member of the object tomatoes. Now, that object that mSeed points to after the call up here exists where? On the heap, right? Does someone say that, or I hope so. Yeah, on the heap. Okay, because we've called new for it, so that part's going to exist on the heap, while the rest of it currently exists on the stack. Now, let me go ahead and add that back in just to add a level of maybe not confusion. First off, let's make sure it compiles and runs. All right, we're good.
Oh, wait, was that called this?
Yeah, because we created a tomato object called TOE, and we created a second object called TOE2. So now we're creating two objects, one on the stack, one on the heap. For TOE2, where does mColor and mSeed reside in? Not on the stack. Remember, right, because TOE2, where's TOE2 is a variable that points to an object on the heap. So its variables mColor and mSeed both exist in the heap as well. What's that?
That was a question I was about to ask. I was thinking about.
Are you still confused? Okay, because I think I'll fix this all up. I'll call this the stack up here. Good. And then, of course, the heap is down here. We have some stuff. Toe is an actual object that has M color right over here, as well as M seed. But M seed is actually a pointer to something down here, which is on the heap. Let me do it this way so it makes a little more sense. So it's down here somewhere. TOE2 actually points to an object over here that has M color and M seed, and its M seed points to a different piece of memory, maybe right here. Does that make a little more sense? All right, so just remember when you have a pointer, there's a level of indirection. You're jumping somewhere. Okay. Any more questions? All right, we are okay. Oh yes, the destruct. Oh wow, these slides did not come out right. Okay, so let's go back to just TOE. It exists on the stack, right? So therefore, is it going to automatically be deallocated for us? If it's on the stack, it's going, yes. I'm saying it over and over again just to help get it straight. On the stack is automatically deallocated for us. So if I run it, remember it's just toe, that's good. If we valgrind it, what do you expect is going to happen? It should be what?
Completely fine.
It should be completely fine. Oh no, definitely lost 1 byte and 1 block. You want to know what that 1 byte is? What does the constructor of toe do? Oh, it's creating an object on the heap. Okay. And for every new, you need a delete. Okay, good. For every new, there must be a delete. Otherwise, you're going to get points taken off in your labs. All right, so C++ has something called a destructor. I've heard people calling it a deconstructor, but that sounds like a villain. It's a destructor, and that is basically the opposite of a constructor. Constructor is called during creation. A destructor is called during destruction, or the deletion of the object. And so what C++ does, you put a tilde, tomatoes, like this, and then we'll go ahead and delete M seed. Whoops, I don't know why I valgrind it. There we go. So this, it starts with a tilde, that means it's a destructor. Are you ever going to have parameters to your destructor? No, why would you? It doesn't make any sense. You're just cleaning it up. Go ahead and delete it, and since it's a pointer, I highly recommend you set it to null. That way you know that you have actually freed the pointer. It'll help you in the long run. All right, so now that we've freed it, we go back, we compile it, and let's go ahead and valgrind it. And now it was freed automatically. All right. So that's how you can package things in objects. Let's see, C++. Oh, okay. So C++ is going to do something that's going to sound awesome, but is actually one of the most evil things I've ever experienced. The semantics of A equals B can be defined. Okay? You can redefine what A equals B means. Right. We are going to do this once or twice and then never touch it again. Well, I take that back. We'll define sub-operators, but not a lot. You can actually redefine equals, plus, double equals, division, minus, multiplication, a whole lot of operations. Okay, why would we want to do this? Well, in certain situations, this makes a little sense. For example, if you have a matrix, you can define what the plus operation is to a matrix. So in this example, if C, A, and B are all matrix objects, if you did C equals A plus B, it would actually call plus on the A plus B, do the addition, and then copy it over into C. So for this, that makes sense. On the flip side, you can then define that subtraction is really addition and that addition really is subtraction. And C++ is going to allow you to do that. So, yes. Hopefully you can see why we're going to kind of avoid this a little bit, because it ends up being kind of a nasty pretty quick. And I'm actually going to keep moving because we're running low on time, but we'll get to this a little more later on. All right. Okay. So, oh boy. All right. Another reason why we're not going to go into OOP with C++ too much. So we're going to have teacher be a subclass of employee. All right. So teacher inherits from employee. Okay. Suppose that promote is a method defined in both classes. It is defined both in employee and in teacher. In Java, if you make an employee E, aka a reference or a pointer to an employee, and then you have E equals new teacher, what does E.promote call? Which function? Right, in Java it would call the teacher's promote function. In C++ it's going to call the employee's promote function, because the variable is a pointer to an employee. Hopefully we'll never have to deal with this, because it's frustrating, but we're going to move on. Yeah, so yeah, employees promotes called because it's determined at compile time and deduce the type of the variable called static binding, while Java uses something called dynamic binding, which doesn't actually figure out which function is being called until the program actually runs. All right, very confusing. Hopefully it will never come up for you, but just keep in mind that C++ is going to have some weird binding. And there are so many more features. I actually don't have time to go into all of them. And this class is not about OOP and C++. So we're really just going to cover a couple more things as the course progresses, and that's it. If you really want to get into C++, there are so many books out there. And I could teach a whole course on it. But I don't want to, and that's not the point of this course. Okay, there are 2 labs today. And it's actually Lab 5 and Lab 6. Before everyone screams, Lab 5 is just pointers again. Because pointers are so important, I'm going to give it to you twice, 2 labs. And then Lab 6 is going to be your first actual programming assignment. So let me go ahead. Thank you. Let's go ahead and at least go into Lab 6 so we can start playing with it. All right.